Okay, so let's have a look at how to do this proof question together. So these proofs involve lots of properties of conjugate and property of modulus. And then one of the most important properties for modulus is z modulus squared equals z multiplied by z conjugate. So if we're trying to prove this big ugly thing, we'll start with left hand side, and then for every single z modulus squared, we're just going to replace it by z multiplied by z conjugate. And then just notice, even you have a big box modulus squared, it is going to equals to box multiplied by box conjugate. So for the first part, so our right hand side, we're going to start with left hand side first. That's easier. So our left hand side equals to the modulus squared minus another modulus squared. Okay, this is a big structure. We don't need to worry about what's inside first. So anything modulus squared is going to itself multiplied by the conjugate. Okay, also minus itself multiplied by conjugate. So just copy down itself first. So this is 1 minus z conjugate w, and this is z minus w. And then you just copy down exactly the same thing under the conjugate sign. Okay. So we're just going to do the conjugate calculation one by one. So if you notice here, the conjugate of z minus w is still just conjugate of z minus conjugate of w. So we can simplify the first part. So this is 1 minus z conjugate w, and then the conjugate of 1, so 1 conjugate still equals to 1, okay, because it is conjugate of 1 plus 0i equals to 1 minus 0i, but this still just equals to 1, okay, so we have 1 minus, okay, so the next part is the conjugate of z conjugate w minus z minus w, z conjugate minus w conjugate. And then let's have a look at this part. So double conjugate become itself. So this will just become z multiplied by w conjugate. And then we'll just multiply the terms out. So we have 1 minus z conjugate w minus z w conjugate plus z conjugate w conjugate. And then minus z multiplied by z conjugate minus, plus z w conjugate plus w z conjugate, and then minus w conjugate. And then we can see there's lots of common things, we can cancel them out. So this term cancelled out with this term here, and this term cancelled with this term here. Okay, and then what's z multiplied by z conjugate? That's just modulus of z squared. What's w multiplied by w conjugate? That's just modulus of w squared. And then here, it will just be modulus of z squared multiplied by modulus of w squared. So this entire thing just equals to the right hand side, which is 1 minus z conjugate squared, 1 minus w conjugate squared. Okay, so we just proved the left hand side equals the right hand side step by step. So this is the first part of the question. And then the second part of the question is an inequality proof. We're going to show z minus w divided by 1 minus z conjugate w is less than minus 1. Okay. So for this kind of proofs, if we don't know where to start, we'll do a simplification first, and then we're just going to copy it down reversely. So let's start with, so this is all on your draft paper. Okay. This is all on your draft paper. So we have z minus w, and then z minus 1 minus zw less than 1. So modulus, so if we have modulus of z divided by w, it just equals to modulus of z divided by modulus of w. Okay, so that's a property we can use. So this would be modulus of z minus w divided by 1 minus z conjugate w less than 1. Okay, and I'm just going to move this to the other side. Z minus w less than 1 minus zw. Okay. and then I'm going to square both sides. Right, square both sides and move this to the right hand side. So I have 1 minus z conjugate w squared minus 1 minus w squared, which is less than 1. Yeah, so if you think about what's this one, this is just the part we proved in the previous part. That just equals to the green part above, which is 1 minus z squared, 1 minus w squared. Okay. Yeah, so now you can see it give it to you at the beginning. The modulus of z is less than 1, and then the modulus of w is less than 1. So those two, they both less than 1. Yeah. So if modulus of z is less than 1, then modulus of z squared is definitely less than 1. Similar for w. Okay, so if the modulus of w is less than 1, the modulus of w squared would be less than 1. And so 1 minus something less than 1 is positive. 1, no, sorry. Yeah. When I change this, it's greater than 0. Okay, so sorry, I made a really silly mistake. Yeah, when you move z minus w squared to the other side, this side just becomes positive greater than 0. Okay. Yeah. So this is less than 1, this is less than 1. 1 minus something less than 1 is positive. 1 minus something less than 1 is positive. Positive multiplied by positive is overall positive. Okay. Yeah. So just stop here. Yeah, we get the ideas. Yeah. So from the top to the bottom, what we did is a simplification question, and then you just copy it in this order. This would be a proper proof. Yeah. So just based on this, let's start with our proper proof. Yeah. So given z is less than 1, w is less than 1. So if you square both sides, it's still going to less than 1. Okay, and then 1 minus z squared is going to be positive. 1 minus w squared is going to be positive. And when you combine those two together, it's also going to be positive. Okay, yeah, so everything so far is correct. And then we're just going to replace this by the absolute value of 1 minus z conjugate w squared minus zw all squared. Okay, yeah, so these two are equivalent, we just proved in the previous part. So that's just also going to be positive. Those two are exactly the same, we just proved in the previous part. Okay. Now you move this to the other side. Okay, so bring this term over to the other side. Okay. And then divide it to the, so divide both sides with z minus w all squared. Okay, and then you square root both sides. Square root both sides. And this divided by this is just 1. Okay, and then square root of 1 is still just 1. Okay, so we have 1 minus zw conjugate divided by the modulus of z minus w is greater than 1. And you can use the modulus properties to combine those two together. Okay, combine those two together. And then also in the actual question, they ask you minus w. Okay, so we can just flip both sides. Okay, so z minus w, 1 minus zw is less than 1. Or right at the beginning, we just move this to the other side. Yeah, so instead of dividing z minus w squared, yeah, so I think a proper way to do it, instead of flipping it later on, let me just quickly redo this again. Yeah, so now we have 1 minus z conjugate w squared is greater than z minus w squared. Yeah, and then now you just need to look at what you're trying to prove before you start the next line. Yeah. So the question asks you to prove z minus w over 1 minus z conjugate w. Okay, so we just need to make sure z minus w is on the numerator, and then 1 minus z conjugate w is on the denominator. So divide both sides by the left hand side. Okay, and then this side just become 1, and then you just take a square root on both sides, and then we have the modulus of z minus w divided by 1 minus z conjugate w is less than 1. Okay, so that's the proper solution for this entire question.